Hi everyone. Today I am going to discuss two more definitions, that is orthogonal matrix, unitary matrix, which is the continuation of yesterday's end class. So yesterday we had discussed many types, operations, basics, definitions, some gate questions. In the end, we had discussed four definitions: symmetric, Hermitian, skew symmetric, skew Hermitian, side-by-side matrices. The left-hand side matrices related to real matrices. The right-handed matrices definitions related to complex matrices. And sorry to say this, that is, kindly excuse me, yesterday in the closing time, where I provided a skew symmetric matrix example. A silly mistake done there. Please, all of you, modify, check this. A is equal to 0, 1 plus I, minus 1 plus I. So, this is the example we are considering now. Compared to yesterday, I considered this element minus 1, minus I think. So, diagonal elements either 0 or purely imaginary. So, this is the simple example of skew Hermitian. Okay. So, from this, find A bar. Every element is replaced by conjugate. 1 plus I conjugate is 1 minus I. Minus 1 plus I conjugate is minus 1 minus I. I conjugate is minus I. Then A power theta is nothing but A conjugate transpose, which is nothing but interchanging rows and columns of A bar matrix. 0, minus 1 minus I, 1 minus I, minus I. So from this, take minus common. That means take out minus. 0, this becomes 1 plus I, this becomes minus 1 plus I. And this has been noticed one of your members, that is, I don't remember that name. So thanks for that person. So which is identified, I have done a silly mistake. So this is minus A. So therefore A is skew Hermitian matrix. Now continuing this, two more definitions which are nothing but orthogonal matrix. Orthogonal matrix followed by unitary matrix. That I am writing here. So number 3. So this is just continuation of yesterday's end class. Orthogonal matrix MAT stands for matrix if A into A transpose is equal to I means identity matrix, is equal to A transpose into A, or transpose of a matrix is equal to inverse of the same matrix, which means that that matrix is called orthogonal matrix. Okay. And some of the points you have to remember in all the definitions that yesterday I mentioned in the brackets and I told you. So to identify a matrix is orthogonal, which one of the following ABCD options is orthogonal matrix? So you have to remember some conditions. Okay. So which takes less time for remembering these points. Determinant of an orthogonal matrix is plus or minus 1. Whenever you calculate determinant, if you have the answer plus 1 minus 1, it doesn't mean that orthogonal matrix. When you came to know that a matrix is orthogonal, definitely its determinant is either plus 1 or minus 1. Okay. So see that example. A is equal to 0, 1, 1, 0. And another example. A is equal to cos theta minus sin theta. This example is very important. Standard example. Sin theta, cos theta. Okay. So for this, I am calculating A into A transpose. That is 0, 1, 1, 0. Transpose of this matrix 0, 1, 1, 0 will give same answer. Matrix multiplication, you know, first row into first column simplifies to 1, first row into second column simplifies to 0, second row into first column simplifies to 0, second row into second column simplifies to 1. Finally, you will be getting identity matrix. From this, I told you this bracket condition, determinant is either plus 1 or minus 1. For example, for this first example, calculate determinant AD minus BC. So, this is minus 1. In this case, after proving like this, A into A transpose is equal to I, calculate its determinant cos square theta plus sin square theta. AD minus BC is equal to 1. So, this is left hand side, the third example, third definition, orthogonal matrix. Okay. Now, in this side, complex matrix. In this side, third example, third definition, unitary matrix. If A into A power theta is equal to I is equal to A power theta into A, or A power theta is equal to A inverse. So, one thing you observe, the difference between the left hand side 3 matrices and right hand side 3 matrices. When you remember the formula or condition for these 3 real matrices, symmetric, skew symmetric, orthogonal matrix, which are related to transpose. On the other side, Hermitian matrix, skew Hermitian matrix, unitary matrix. They are obtained just transpose is replaced by theta. What is theta? Transpose come conjugate. Okay. That is. So, in this example, A is equal to 1 plus I by root 2, I value root minus 1, 0, 0, 1 minus I by root 2. So, all of you please check this, A bar, how much you are getting, and A power theta, then finally multiply these two, A into A power theta. Okay. So, definitely you will get 1001. Please verify. So, and one important property or point I am telling you in orthogonal matrix, when the question related which one of the following ABCD is orthogonal matrix A 3 by 3 or 4 by 4, by verifying this condition takes more time whether the answer is option C or option D. In such cases, not only this condition that A is equal to plus or minus 1, but also you remember, if a matrix is orthogonal matrix, then every 2 rows or 2 columns, that means every 2 vectors are orthonormal vectors. What is the definition of orthonormal vectors yesterday? Dot product is 0, length of each vector is 1. For example, in both examples, 2 rows, I mean 2 vectors. 2 vectors means either 2 rows or 2 columns. So, take 1 by 1 vector, find the dot product, definitely you will get 0. Length of each vector, that means length of each column or each row is equal to 1. For example, this is first vector, first column. This is second vector, second column. How do you find dot product? Corresponding elements multiply and then add. 0 into 1 plus 1 into 0, 0. So, dot product of the 2 columns or 2 rows is 0. Length of each column. So, this is first column elements 0, 1. What is the length of that column? Root over 0 square plus 1 square, that is 1. Length of the second column, that is root over square root of 1 square plus 0 square equal to 1. Similarly satisfied row wise. Similarly satisfied this is also. So, when a matrix is orthogonal matrix, immediately you remember the condition, dot product of every 2 rows or 2 columns is 0. Length of each row or column is always 1. Okay? That means dot product of every 2 vectors is 0 and length of each vector is 1. That is called orthonormal vectors. Okay? So when you notice that the dot product of every 2 rows, 2 columns is 0 and length of each row, comma column is 1, such a matrix definitely orthogonal matrix. So now I am going to start rank of a matrix. Before that, minor of a matrix, which are useful for finding rank of a matrix, or by the help of elementary operation we can find the rank of a matrix, followed by system of linear equation. That is today subtopics. Determinant, take care this point, of an R cross R submatrix of a matrix A is called a minor of order R. So suppose A is a 2 cross 3 matrix, A is a 3 cross 3 matrix, whether it's square matrix or rectangular matrix. You know the meaning of submatrix. What is submatrix? Deleting row or deleting column, deleting rows comma columns. The matrix so obtained is called submatrix of the given matrix A. So when you delete some row or columns or both, if you have a 2 cross 2, a 1 cross 1, a 3 cross 3, which are called submatrices of the given matrix. The determinant of each, this 1 cross 1, 2 cross 2, etc. R cross R, submatrix of a main matrix A is called a minor of order R. For example, if there is a 1 cross 1 submatrix in a matrix A, the determinant of 1 cross 1 is called a minor of order 1. There is a 2 cross 2 submatrix in a main matrix A. The determinant of that 2 cross 2 submatrix is called a minor of order 2. Okay, please remember. For example, A is a 3 cross 4 matrix. How many types of submatrices? In a 3 cross 4 matrix, which is a rectangular matrix, there are 1 cross 1 submatrices, deleting 2 rows, 3 columns. There are 2 cross 2 submatrices. There are 3 cross 3 submatrices. Okay, so determinant of 1 cross 1 submatrix is called a minor of order 1. Determinant of 2 cross 2 submatrix is called a minor of order 2 for the given matrix A. Determinant of 3 cross 3 submatrix is called a minor of order 3 of the given matrix A. So for a matrix A, there are so many minors depending on the submatrix size. That means 1 cross 1 submatrix, 2 cross 2 submatrix. So depending on the submatrix order, the minor value changes. But minor of an element is single answer. Minor of a matrix is depending on the submatrix order. Minor of a matrix is not unique because it has more submatrices. Okay. Definition. Row echelon form. A matrix A m cross n. A m cross n means maybe a square matrix or rectangular matrix. Is said to be in row echelon form, comma, if the following conditions are satisfied. Condition number 1, 0 rows, if any, belong at the bottom of the matrix. number 2. The number of zeros before the first non-zero element in each row is less than such zeros in its next rows. See, let us start row by row. Let us go to first row. Identify the first non-zero element. Give an indication, a tick mark or a line, underline or a circle for the first non-zero element. Before means left side, after means right side. So, for every first non-zero element in every row, identify the number of zeros, count the number of zeros. That should be increases from first row to second row to third row till last row. So, zeros must be increases when coming from top to bottom, that is top row to last row. Which type of zeros? Before the first non-zero element. Okay, for example, in a given matrix, the first element is 0, the next element is 2. So 2 is the first non-zero element. Let us take second row, 1, 2, 3, 4. So 1 is the first non-zero element in the second row. Let us take a third row, 0, 0, 0, 1. So first 3 elements 0. The last fourth element is the first non-zero element. Okay, so what is 0 row? A row has all elements zeros. Such 0 rows should be in the last of the matrix, that is bottom of the matrix. Suppose in the given matrix A, the first row, all elements zeros, you have to shift into last row. That means interchanging of 2 rows. So, when you interchange 2 rows, 2 columns in a matrix will not be affected by sign. But if you interchange 2 rows, 2 columns in a determinant, it will be affected by minus sign. Please remember the difference between matrix and determinant. In a matrix, you can apply any type of row operations, column operations. It will not affect. It is called equivalent matrices. A matrix B is obtained from another matrix A by applying a row operation or column operation. Such a matrix is called an equivalent matrix. Okay. Equivalent matrices having same order and same ranks. Okay. So what is the purpose of this row echelon form? It gives rank of a matrix C. Rank is always a non-negative number. Okay. For a non-zero matrix, rank is always non-zero. For a zero matrix, rank of that matrix is 0. So how do you find the rank of a given matrix? When a matrix satisfied these 2 conditions, that is row echelon form. Once you make a matrix A into row echelon form by satisfying these 2 conditions, the number of non-zero rows is called rank of a matrix A. Okay. So here I am writing the number of non-zero rows is called rank of matrix A. If A is in row echelon form. Okay. When a given matrix is row echelon form, then only the number of non-zero rows is called rank of a matrix A. See, simple example. A is equal to 1, 0, 2, minus 3. 0, minus 1, 4, 0. 0, 0, 0, 0. I consider a 3 cross 4. 3 rows, 4 columns. So let me check. So I am giving an indication by a circle which indicates the first non-zero element in a row. In the first row, 1 is the first non-zero element, which is indicating by a blue circle, blue color circle. Now, in the second row, the first non-zero element is minus 1. Now, in the third row, there is no non-zero element. Let us check. 0 rows. The third row is a 0 row, all elements zeros. Belongs to last of the matrix, that is bottom of the matrix. Okay? This first condition is optional. If it is available in the matrix, then only you put into the bottom of the matrix. If it is not there in the given matrix, then optional condition. That is condition 1 is ignored. Condition 2 is very, very important. Okay? What is that? Before the first non-zero element of each row. So this is first non-zero, first row. This is the first non-zero element. Before means left side, no zeros. That is 0 zeros. Go to the second row. This is the first non-zero element. Before, that is left side, 1 0. In the first row, no zeros. In the second row, 1 0. It is increases or not? Number of zeros increases from first row to second row or not? Next. So, strictly speaks that, okay, elements below the diagonal 0. Actually, we should not talk diagonal elements in a rectangular matrix. For understanding easily, you have to make the elements below the diagonal 0. That is called upper triangular matrix form. So, such a matrix is called row echelon form. For example, see. First diagonal, second diagonal, third diagonal. So, this is an indication by a slope line, blue color line. Elements below these, zeros are not. Okay? So, such a matrix is called row echelon form. What is the use of this? Finding rank of a matrix. What is the use of rank of a matrix? Solving the given equations. Not like 8th, 9th, 10th class, 12th standard. 2 equations, 2 variables, 3 equations, 3 variables. It is any number of equations with less number of variables, more variables, less equations. Any type of equations can only be solved by this rank method. That is the main advantage of rank. So, implies A is row echelon form. How many non-zero rows? The first 2 rows are non-zero. Since it has 2 non-zero rows, therefore, rank of A, matrix A is 2. Okay? So, properties. So, when I do problems, I will justify these properties one by one. Okay? Number 1. Instead of properties, first we'll discuss the notation. Rank of a matrix A is denoted by R of A or row of A. Row stands for Greek letter here, which is useful for rank of a matrix symbol. This row is a Greek letter which stands for rank of a matrix symbol. Next, rank of a null matrix is 0. In null matrix, there are no non-zero rows. That's why rank of a null matrix is 0. And rank of any other matrix is always greater than or equal to 1. Apart from 0, what is the next numbers? 1, 2, 3, 4. So, rank of any other matrix greater than or equal to 1. Okay? Rank of a null matrix is 0. So now I am going to provide some matrices for finding rank of a matrix. So you have to make all that given matrices into row echelon form, then only we can decide rank of a matrix A. Okay. Find the sorry rank of the following matrices. Number 1, this question asked in 2014. A is equal to 6, 0, 4, 4 minus 2, 14, 8, 18. 14 minus 14, 0 minus 10. 3 cross 4 rectangular matrix. Number 2, 2006. A is equal to 1, 1, 1. 1 minus 1, 0. 1, 1, 1. Number 3, 2019. A is equal to 0, 1, 1, 1, 0, 1, 1, 1, 0. One is rectangular matrix, other is square matrix. So the first one solution. Go to the first row, the first non-zero element, which is highlighted by blue circle, that is 6. So our aim is elements below the diagonal 0. That means following row echelon form, the number of zeros before the first non-zero entry in each row should be increased from first to second row to third row, etc. Indirectly means that elements below the diagonal 0. That is, you should make upper triangular form, which is nothing but row echelon form. So now I have to make the down elements for 6, that is minus 2, 14, to be 0 by using row operations only here. This minus 2 is R2 element, 6 is R1 element. How do you get here 0? First I have to multiply by 3, then adding with R1. That is 3 into minus 2 plus minus 6. Adding with plus 6 becomes 0. So that is the first row operation. Okay. So these type of operations I already shown you in determinants also. R3, 3 times R2 plus R1. So what is the meaning? Here 6 is located in R1. Using that 6, we have to make exact down elements 0 by applying row operations. So in the next step, R2 only changes. So while writing these operations, the first one will affect in the next step, but not in this second position. This is position, second row position, here first row position. Which one I wrote first? R2. So R2 only changes in the next step. Similarly, we have to make 14 0. 14 is in third row. So with the help of 6, we have to make 14 0. So which element to multiply here and then here? Next adding, subtracting will give 0. So if I multiply by 3 here, 3 14s are 42. And here multiply by 7, 7 6 are 42. 42 minus 42, that is subtraction row operations. Addition row operations, subtraction row operations, any one of these. After multiplying a proper common multiples. Okay. So applying 3 R3 minus 7 R1. So these two operations on a given matrix A, you will be getting equivalent. This symbol stands for equivalent. That means when you operate a row operation or column operation in a given matrix A, you will obtain another new matrix. That new matrix is called or is said to be equivalent to the given matrix. Okay. So this is the given matrix. This symbol stands for equivalent. Doesn't matter about writing all this, because your final approach answer, and whether it is in ABCD options or numeric question, you have to see that. So here R2, R3 changes accordingly these type of row operations. So R1 remains same, 6, 0, 4, 4. R1 doesn't changes, because I mentioned R2, R3 according to these row operations it will changes. So now take care in this, hold like this. These two fingers, one finger shows R2 row and the other one is R1 row. So first here multiply by 3, use mind calculation. 3 into minus 2 plus R1. R1 element is 6. So minus 6 plus 6, 0. Next, hold like this. 3 into 14 plus 0. Keeping this point in mind. So 42 plus 0, 42. Next, move like this. Okay, because we are applying R2 with R1. 3 8s are 24 plus 4. Simplifies to 28. Next, 3 into 18 plus 4. That is 54 plus 4, 58. So this is the new elements of second row R2 by using this type of operation. Similarly, you will get new elements of R3 by using this operation. So now expand your fingers length. So one finger shows to R3, other one is R1. Which type of row operation? Here you multiply by 3, here you multiply by 7 and then subtracting. So 3 14s are 42 minus 7 6 are 42. So 42 minus 42, 0. This is I already told you. Next, move like this. 3 into minus 14 minus 7 into 0. So minus 42 minus 0 simplifies to minus 42. Move like this. 3 into 0 minus 7 into 4. So 0 minus 28 simplifies to minus 28. Next, 3 into minus 10 minus 7 into 4. So minus 30 minus 24 simplifies to minus 58. So these are the last row elements, is the new elements of third row. Okay. Next. So first row step over. Come to the second row. So where is the first non-zero element? That is the diagonal element. So 42 is the first non-zero element. So again, what is our aim? You have to make its exact down element 0. What is the exact down elements? That is below elements only minus 42. So this minus 42 is in third row. This 42 blue color circle is second row. So you have to apply a row operation between R3 and R2. So here 42, 42 same numbers. So either you add or subtract depending on the symbols available there. So minus 42 plus 42 gives 0. That means I am going to apply the row operation R3 plus R2. So equivalent to. So again you will get another matrix, new matrix by changing only R3. Because I took only one row operation, which is the first I put here R3. So in the next matrix, R3, third row only changes. First row, second row unchanged, remains same. That means these are the first row, second row, no change. You will be getting as it is 6, 0, 4, 4, 0, 42, 28, 58. Next 0, hold like this. Because I took the operation R3 with R2. 0 plus 0, 0. Minus 42 plus 42, 0. Minus 28 plus 28, 0. Minus 58 plus 58, 0. 0, 0, 0. So come to the third row. There is no non-zero element. So problem is over. So now below the diagonal elements, we got 0 or not? This is upper triangular form. So how many non-zero rows? So first of all, this is row echelon form. Okay. So how many number of non-zero rows? 2 non-zero rows. Okay. So therefore, rank A, row symbol stands for rank, is equal to 2. What is that 2? 2 non-zero rows. What is the rank of a matrix A definition? Number of non-zero rows after the matrix A satisfying the row echelon form conditions. That is the easiest method. Okay. In material or any textbook, they have provided using minor methods also. That is determinant method also. That is 2 cross 2 determinant not equal 0, 3 cross 3 determinant not equal 0. That method is also useful, very rare case problems. In some situations that is useful. But it is the better method using row operations, row echelon form method. When it is necessary, I will come to that method also. Don't worry. Now, second problem solution. See, this is the first non-zero element in the first row, 1. So we have to make its down element 0. This one, this one. This one is second row. This one is third row. So we have to apply 2 row operations, that is, which are R2 minus R1 and then R3 minus R1. When you have the first non-zero element is small numbers 1 minus 1, the row operations becomes easy. Will feel easy, will take less time also. Not like this, 6 and 14 like that. Okay, in that case, a little bit time more. So, applying R2 minus R1 and then R3 minus R1. In these two operations, R2 changes, R3 changes will give a new matrix equivalent to 1, 1, 1, 0, minus 2, minus 1. So, I shown you my fingers in the previous example. The same way you can apply. Easy to understand. Next, 1 minus 1, 0, 1 minus 1, 0, 1 minus 1, 0. Okay. So, this is the first non-zero element in the first row, first non-zero element in the second row, below the diagonal 0. And I can show my second condition of row echelon form satisfied. Before this one, no zeros. Before this, minus 2, first non-zero element, 1, 0. So, zeros increases from first row to second row to third row. Last row containing zeros. Here also last row containing zeros. It is not sure in every problem. If it is there, it has to satisfy. Otherwise, it is optional condition, first condition. So, here also, before 6, no zeros. Before 42, 1, 0. Correct or not? This is the first non-zero element. This is the first non-zero element. Before the first non-zero elements, please count the number of zeros in every row, which should be increasing level. That is called row echelon form, which is also upper triangular form, that is below the elements below the diagonal 0. That is our aim, to find the rank of a matrix. And then number of non-zero rows is called rank of a matrix. So, how many non-zero rows? 2 non-zero rows. Okay. Since it has 2 non-zero rows, therefore, rank of this matrix is equal to 2. Next, for this example, see. Here, this is the first non-zero element. Here, diagonal element 0. Okay. So, if I consider this is first non-zero element, I can make its down element, that is this 1, R3 element, 0, because it is already 0. I cannot make this element 0. Okay. So, that means here you remember one important point. We always give the priority a first non-zero element, the first non-zero element to the diagonal element position. Okay. That means take care about diagonal elements. If any diagonal element is 0, don't move in the right hand side by taking the first non-zero element. If any diagonal element is 0, look at its down elements. If any one of the down element is non-zero, bring that element into the 0 element position by interchanging row operations. For example, the first diagonal element 0. Below elements, there are 2 non-zero elements. Any one of the elements you have to bring back into first diagonal element, so that we will be getting a first non-zero element in the diagonal position. So, priority given to first non-zero element at diagonal element position, which is easy in the next matrices, next operations. Okay. So what I am going to do, I want to interchange these two, that is R1, R2. Don't put minus outside. When you interchange 2 rows, 2 columns, the determinant value is affected by sign. But in matrix, there is no effect. You will be getting equivalent to a new matrix 1, 0, 1, 0, 1, 1, 1, 1, 0. Now let us start. This is the first non-zero element. So we have to make its down element 0. Already R2 element 0. We have to make this 1, that is R3 element, with the help of this R1 0. So applying R3 minus R1 equivalent to, so R3 only changes in the next step. R1, R2 remains same, 1, 0, 1, 0, 1, 1. Now hold like this, 1 minus 1, 0, 1 minus 0, 1, 0 minus 1, minus 1. This is the next step. In the next row, second row, this is the first non-zero element. So we should make its down element 0. Here, this one is R3. This one is R2. So we should apply a row operation between R3 and R2. So that means R3 minus R2. 1 minus 1, 0. Equivalent to. So in this step, R3 changes again. R1, R2 remains same. 1, 0, 1, 0, 1, 1, 0, 0 minus 0, 0, 1 minus 1, 0, minus 1, minus 1, minus 2. Now come to the third row. This is the first non-zero element. No more its down element. So problem is over. So 3 non-zero rows. So before this one, no zeros. Before this one, 1, 0, increase. Before this first non-zero element minus 2, 2 zeros. So number of zeros increases from first row to second row to third row, which is nothing but elements below the diagonal 0. That is called row echelon form or upper triangular form. Okay, this is slope below the diagonal 0. So this is row echelon form. Now onwards, I want to write in short form echelon form, because in the first two examples I wrote full form row echelon form like this. Here is row echelon form, here also is row echelon form. Now onwards, if it is repeated, I want to write row EF. EF, capital E, capital F stands for echelon form. Please remember everyone. So, how many non-zero rows? 1, 2, 3. Number of circles in my notes, it is called number of non-zero rows. Therefore, rank A is equal to 3. Now, based on the above examples, some properties are useful, which are for other examples also. At a glance, you have to remember which are helpful for 1 mark statement questions or some problems. Number 1. This stands for rank of a matrix. A m cross n less than or equal to minimum of m comma n. What is m cross n? It is the order of the matrix A. M stands for number of rows, n stands for number of columns. Rank of any matrix never greater than rows comma column, number of rows comma number of columns. So rank of any matrix less than or equal to rows as well as columns. That is minimum of rows comma columns. For example, in the first example, this is 3 cross 4 matrix or not. So m value 3, n value 4. Minimum of 3 comma 4 is 3. So rank of this matrix less than or equal to 3. Okay, according to this property. We got rank A2. 2 is less than or equal to 3 or not. Coming to this, 3 cross 3. M is equal to 3, n is equal to 3. Minimum of 3 comma 3 is 3. So rank of that matrix less than or equal to 3. We got answer 2. 2 is less than or equal to 3 or not. Coming to this, 3 cross 3 again. So m value 3, n value 3. Minimum of 3 comma 3, 3. So rank of that matrix less than or equal to 3. We got exactly 3. Less than or equal to also. Okay. So rank never greater than number of rows comma columns. It is always preceding. That is less than or equal to rows comma columns. Minimum of rows comma columns. Now, number 2. Rank of a row slash column matrix is 1. For example, if I take 1 minus 2, 3. This is one row, 3 columns, row matrix. So this is the first non-zero elements. There are no down elements. How can I make 0? So this is itself is called row echelon form. Number of non-zero rows is 1. So rank of a row matrix is 1. Similarly, you can verify column matrix also. Okay. Next, number 3. Rank of a matrix A is same as rank of its transpose is same as rank of A transpose into A is same as rank of A into A transpose. So this one also related to 2016, 2015, etc. See, when you want to prove any property, yesterday I told you, take a 2 by 2 matrix, which will take less time, which is satisfied any matrix, 3 cross 4, 2 cross 4, anything. Take a 2 by 2 matrix, find rank, as above I shown you, 3 by 3, 3 by 4, just like 2 by 2 also you will get it. Find A transpose. So for that matrix also use the above method, rank. So both are same, A into A transpose, multiply. For that matrix find rank, which is same as A. This is also same as A. Okay. Next. Number 4. Rank of A n cross n is equal to n implies and implied by A is non-singular matrix. Rank of A n cross n less than n implies and implied by A is singular matrix. See, yesterday I told you in determinants definitions, what is non-singular matrix? Determinant not equal to 0. When a matrix determinant not equal to 0, such matrix having rank is order itself. N is called order of the matrix A. See, for example, here in third example, okay, determinant 0, 1, 1, 1, 0, 1, 1, 1, 0. I am finding for this matrix determinant. So determinant can be expanded by any row or any column. The first one, 0 into, what is that empty bracket writing? Nothing there. That means 0 into anything is 0. I shown you yesterday. Next, the second element multiplied by minus, that is minus 1 into, deleting second column first row, 1 into 0, minus 1 into 1, that is 0 minus 1, plus the last element into plus 1 into, deleting third column first row. These are the 4 elements, submatrix, determine 1 into 1, minus 1 into 0, 1 minus 0. So how much this will be getting? 2. 2 not equal to 0. So this is determinant A. Therefore, A is non-singular. SING means singular matrix, short form. So for this matrix, how much we got wrong? 3. What is the order? N cross N? 3. So when it is a non-singular matrix, rank of that matrix is equal to order of the matrix. Understood or not? Coming to this, for example, the determinant A is equal to determinant 1, 1, 1, 1 minus 1, 0, 1, 1, 1. Okay. So for this determinant, directly 0, since row 1, comma row 3 are identical. When 2 rows or 2 columns identical means same, such a matrix having determinant 0. Or you can expand by determinant procedure, you will get 0. So this is 3 cross 3, n value 3. Rank of this matrix, how much we got? 2. 2 less than 3. So that's why rank of a matrix less than its order provided that matrix is singular matrix. Okay, that is both sides satisfied, if and only if. These are helpful in some problems, 4 cross 4, 5 cross 5, etc. So in this, so for the question, I mean, very, very important. Where I put very, very important, the gate questions also previously asked on that. Number 5 onwards, 2 more points, 2 more properties you have to remember as a formula property. They can ask statement directly. Okay, so rank A plus B less than or equal to rank A plus rank B. And last property, rank of a product of matrix, that is rank AB, less than or equal to minimum of rank A, comma, rank B. So rank of a product never greater than either of the ranks. That means it is preceding each of the ranks. Rank of a product of the matrix is less than or equal to either rank A as well as rank B. That is minimum of rank A, comma, rank B. Okay. So rank of a matrix is unaltered by applying any row operation, column operation. That is I already shown you. So these are the 6 properties. First 4 properties related gate questions previously asked. That is I already shown you 2 problems. So in the next time, I mean next hour I will do 1 or 2 problems based on these properties. Then you understand the beauty of these properties. Okay. So all of you take break.